solution? Yeah, so negative log of whatever x is. And then the concentrations of the other species are pretty easy because you just plug in x into your race chart and solve. But there's only two different ways you can do a race chart, right? There's I want to know the Ka or I want to know the concentrations at equilibrium. There's only two ways that you can have a race chart problem. This is one of the two types of problems. Like they're giving us the Ka, they're asking us for the concentrations at equilibrium. The other version would be they don't give us the Ka, but they give us enough information to figure out what x is equal to, and then you can algebraically yourself for Ka. So it's very similar to the last chapter in terms of the approach or the method for solving for these. Just raise your hands. Questions on over? James, are you good with this? Did you miss this when we did this yesterday or Tuesday?
No, I remember that.
Oh, you did?
I just like learned how to apply it. I forgot about
So for number 3, those are all strongs, right? So you don't have to do race charts for number 3.
Oh, I'm on number 6, I guess.
Yeah, for number 6 is race chart. 4 and 5 are also kind of race charts. We'll do more practice with that later. How do we feel with this stuff? Are we okay with this? Are we comfortable with this stuff? We'll do more practice, don't worry, but just for now, this is a good bulk of what this unit entails. Figuring out what they refer to as predominant. What's predominant at equilibrium? What is driving the pH? What's the biggest contributing factor to the pH? So we'll be playing with that a lot more for the rest of the unit. Today's lab is Le Chatelier's principle. Remember last week we were supposed to do this lab, but we got our block days canceled because of the snow day, so we're doing it this week. So I'm going to pass out your lab. You're going to do the pre-lab question on the second page. It's just shifting. You could ignore any markings on the material. I was having Smith do some inventory for me, and he wrote on the original copy, like a good TA. So just ignore the markings about the checks and the X's and the question marks on the material. You guys ever listened to American Fiasco? You listen to that? About like the men's national team in the 90s over the summer? It was like a big podcast with them. You listen to it? No? What about you, Tom? No? Never heard it? You should listen. I think you guys would like it. All the summer. Yeah, it's like a Lindsay Wallace with like all the other things. Cooper, you listen to American Fiasco podcast? About like the U.S. men's national team and like back at the World Cup. Oh, yeah. It's really good.
Put it closer.
That's really not
Going.
how it works.
It's like they had this juggernaut team in like the late 90s and they were supposed to like win all of it. It's like internal turmoil or whatever. It's like the stuff that they like kept under wraps for like 20 years or something. No? Ever heard of it? It's Bob Lee. It's an ESPN like American Fiasco. It's like late. I want to say it's late 90s, early 2000s World Cup trip. Choking like the artists, underperforming the artists. It's all like the. And I also talk about like why soccer isn't like as big in this country as it is in like all the European countries. I think it's pretty cool. It's worthwhile. All right, can you do the pre-lab questions, please, or just let's just tell you shifting? It's only 2 questions. Yeah. So, 2 questions, 290. And then we're going to do the introductory activity. Once you're done with those.
Soccer doesn't stay fast. I've tested the state of
That's just like, what's the final score? Oh, 0-0. That's the worst.
I understand soccer. I have a brain. I get it. You take the ball. It's obvious. It's basketball on soccer. It's not.
Not at all. Not at all.
It's a lot of geometry. It's a lot of geometry.
No.
It's the triangle. You gotta
It
get
is
the triangle.
What do you think they? What do you think it's like?
It's like I played FIFA. I know. It's just triangle.
Tommy, do you want like a dark green?
I agree.
I think the solubility of iodine increases because, I mean, I don't know if there's more for the reaction, we'll have more. Just write that.
Oh, you mean the 300? Yeah, I played that a couple years ago with Mr. Cody and someone else. We got like they just shot threes over us the whole time. Mr. Cody's tall, so you can just chill under the rim and like protect the rim. But they just shot threes and we lost so bad. Like they hit three. It's like alright.
Sorry, you should come to morning soccer.
Morning soccer.
Like that, usually, I come late every day.
Is it like Friday morning? Like I come late.
I come late all the time. The only people that are on time are
Hey, Claire. Claire, hop onto the live stream. Hop onto the live stream.
I don't go on Tuesday. I'm chamber orchestra. You know that. Yeah, but a lot of. Yeah, but I can't wake up. I can't do that. It's too early. I come Fridays though. Amanda doesn't even show up all the time.
Take a solid late before you got We watch a lot. We watch like a lot of
Nice.
What's up? We're not watching public shows. What is wrong with it? Aggressively live. Also not okay. Not okay. Not okay.
This 600 is so good.
That's more of a thriller, yeah. That's much more acceptable.
So good.
We could watch The Village. What? Oh, I got a really good idea for a movie.
What do you want? Which one?
No, because
You got one. Oh, did they advertise? Top right corner.
Are you sure it's actually?
Top right corner of the power button.
Do that?
It looks like the power button. Like here, if this is the computer. Up here. Power button.
The video title
I thought I
is
disabled them all.
something.
Sorry if I didn't.
No, it has to be
Who does that?
lab. Have lab.
I know, I'll make it.
Really? But did you just switch on somewhere else?
Yeah. And that might, you don't need it. The world is but you need this to learn. Why are you being Scott? My name is Scott. Oh, it's a waking dream.
Yeah, I only have. I don't have legal and stitch. But that would also be something. Sixth Sense is non-violent, right? That's PG-13, right?
Mr. Diamond, I'm telling you, The Village is a good movie.
Yes.
What?
So good.
What is it?
Yeah,
Yeah.
James Bond.
Oh, yeah, I was. But in that show, when he was good.
Yeah, but what?
That's what we're doing.
I got a live stream to 10 too.
That's the water bottle.
Man, it's so good.
It was spoiled for me, so I didn't cry.
Water bottle.
The face
No.
Put this here.
It's like, no, you see it?
Put it right
It was in the theater like last week.
Because Mr. Diamond will see that. Whenever you
Oh, are you live streaming on your phone?
You should watch
Yeah.
Little Hunted.
Oh, well, put this in front of
That is a great movie.
Just don't let Mr. Diamond.
Yeah, Mr. Diamond sees will get mad.
the No, we're not live streaming.
We are.
No, we're not.
Oh my god.
It's not.
You suck again.
I can't do it.
You can't see the screen.
It's not working.
Stop.
Claire?
Alright, are we done with the two pre-lab questions?
Wait, I just see myself too. Let's do it this way. No, we won't.
Alright, number one says, use Lechatelier's principle to explain why the solubility of iodine in water increases as the concentration of potassium iodide increases. What do you think? Lechatelier's principle, shifting what? Any takers, any ideas? Oh, go ahead, sir. Yeah, James, how about you answer?
I already gave my answer. I said 7.
7 is not the answer.
Okay.
So basically, I said that as a concentration of potassium iodide. How much, so does the iodide ion, so when the iodide ions increase, it shifts right. So, that means it favors the products, and when it favors the products, that means that more reactants have reacted, I guess, so.
Excellent, perfect. That's it. Shift away from an increase, right? So if you add potassium iodide, right, that's Ki. If you put that in solution, it's going to break them into K plus and I minus. So really, it's like a sneaky way of increasing the concentration of I minus by adding a common ion. This is like common ion.
So like, if this equilibrium is supposed to keep going like forever, why can you like have so much solute in like a thing that it doesn't dissolve?
Because there's still only so many water molecules that can surround the solute ions in order to solvate them. And then eventually, the water molecules that they've used up, essentially, you just run out of water molecules.
So like,
So then the solid will just settle to the bottom.
years it works
To a certain extent.
like before they are like super saturated.
Fully saturated,
Fully
yeah.
saturated?
Correct. You go. Number 2 says, although both N2 and O2 are naturally present in the air we breathe, high levels of NO and NO2 in the atmosphere occur mainly in regions with large automobile or power plant emissions. The equilibrium constant for the reaction N2 and O2 is to give NO is very small. The reaction is, however, highly endothermic, with a heat of reaction equal to positive 180 kilojoules. So it says, use Lechatelier's principle to explain why the concentration of NO at equilibrium increases when the reaction takes place at higher temperatures. Any takers? Excellent. So your stressing the left side of the reaction by doing it at a higher temperature, yeah. So you're essentially increasing that 180 kilojoule value, because this is an endothermic reaction that is being absorbed. So you expect it to shift to the right to make more NO to relieve the stress of you doing this at a higher temperature. Letter B says use Le Chatelier's principle to predict whether the concentration of NO at equilibrium should increase when the reaction takes place at high pressure.
The moles of gas are equal on both sides of the reaction, the question is going to have an effect.
Excellent, good. So for letter B, you're just saying no effect. You have 2 moles of gas on the left, you have 2 moles of gas on the right. So no shift is going to occur if you mess with the pressure. Any questions about these pre-lab questions? These ring a bell from last chapter? Equilibrium. Right, there's only so many ways you can stress a reaction. You can mess with the concentration, you can mess with the temperature, you can mess with the pressure. You could increase any of those things, you could decrease any of those things. And remember, Le Chatelier's principle says that you're going to shift in such a way that it's going to relieve the stress that you're putting on a system that's already at equilibrium. All right. So for the lab today, you are going to do the introductory activity on the 3rd page of the lab, part A, effective concentration, and then part B, effective temperature. This is more just read the directions and the procedure and do the stuff. This is supposed to give us a baseline of looking at an equilibrium reaction and then stressing it with different things. So what I'm looking for you to do is this is going to be very heavy on your observation. So I need you to make a chart of procedural step, procedure, and we do like a T-chart like this, procedure, and then observation. I have kind of 2 sets of chemicals available because obviously everyone needs access to these. So I'm going to put 1 set of chemicals in the fuse hood. And then I'm going to put 1 set of chemicals on my desk. That way we don't all have to wait in line. We could, divide and conquer as well. You and your partner don't both need to be up here getting stuff. The effective temperature is going to be an ice bath and a hot water bath. So I'll go get ice in a little bit so it doesn't melt. And then I have test tubes up here for you to use for part B. There is only 1 bottle of the potassium thiocyanate, so that's going to be in the fuse hood to start with. You need 20 milliliters of it. So use one of the graduated cylinders at your island, get 20 milliliters of it, bring it back to your station. Everyone is going to need a petri dish to do the reactions in. So I'll put those up on my desk as well.
6 people are watching.
And then when you get to the stuff that's asking you to do like pea-size amounts of potassium nitrate and potassium thiocyanate and sodium phosphate, there's 1 set of chemicals up here, there's 1 set of chemicals over there. I think the first thing you have to put in though is iron nitrate solution, so there's obviously some up here and there's some over there as well. When it says pea-size amount, just use your kind of best judgment with it. It is pretty small. It also even says put like a 1/4 pea size, which is incredibly small. You're just putting like a little tiny amount in. Any questions before we start? The procedure is pretty straightforward for both part A and part B. You just gotta follow the instructions and do the things. And the big thing that you need to do is, again, make a procedure and observation situation here. You should number these, like what did you do and what's the observation, right? Number these like 1, 2, 3, 1. I can count, I swear. Something like that. You're going to use like different parts of the petri dish to see how things behave. I'm going to give you like a toothpick to start. Yeah, that's okay though, because like you're gonna have an equilibrium established, then you're gonna stress it, and it's gonna re-establish equilibrium, and then you can stress it again. So it's kind of like the graph that we did before, where like you made the graph, then you with the straws, right? Then you stress the equilibrium and it go again. Yes.
So are you doing like part A, part B, or are you
Yes.
doing just A?
No. You're gonna do part A, part B, then you're gonna analyze the results. And then the activity A, B, C, D, E, we will do another time. That's the whole other piece of the time. This is just to give you ideas of what kind of stresses you can put on the equilibrium system, and again, being able to see how it's going. Yes.
Just to analyze the results, you have to.
Yeah, you're just gonna do analyze the results. You know, I mean, ideally, I'd like you to have time to work on it before the bell rings, but if you don't finish, just do it wrong. All right, here are your partners.
I feel bad for whoever's
Boom, there you go. There's a group of 3. Emily's again.
We're 11.
Edward.
Oh my god, that is a scary combo.
All right, let's do it. Can you put your bags on your
Super
please?
cool
Grab
live
them.
stream.
Thanks. No, and I'm keep that. 8?
Yeah.
We're gonna find it together, okay? Oh, my apple is bruised.
Why not? Are they great?
What the?
I have
Where's
them-
the live stream?
It's my pocket.
Oh, good.
You think it's over? It's not gonna be over. Don't go until my phone dies. Where's Edward? Edward.
Need 2 beakers total. 1 for hot, 1 for cold.
What else can I start getting for the live stream?
Petri dishes are up here. Make sure you grab a petri dish.
Alright.
One number.
Is Cooper here? Cooper?
No, he's dead.
Yeah, he's here. He's bloody hell. You need both sides. I don't know. He's your partner, right? Yeah. This is gonna be miserable. I love it. Alright.
Oh, nice, man. The streams.
You finally made it.
Famous.
This stream is called Hitting Something a lot of times. I've been
Solutions in the
hitting
fume. You need 20 milliliters of it.
Do you want to get all the stuff that you can find at our island?
yeah.
And then I'll get stuff you can't find.
How do I end it?
What I did.
To my desk when you're done with everything to put into the waste speaker. Don't dump it down the drain, please. Two beakers. For the introductory, you only need 2. I promise. There's one for